Hello students, in this video we will solve another kind of a numerical based on series RC circuit. So let's read the numerical first. The expression for voltage applied to a series circuit is E is equal to 120 sin 314t, whereas current drawn is expressed as I is equal to 10 sin of 314t plus pi by 6. Pi by 6 radian is equal to, here it is in this case 30 degrees. Calculate the values of components of the series circuit. Calculate the active and reactive power consumed by circuit. So look at this. This is very good numerical. Here we are supposed to find components involved in this series circuit. So we have to find out what is the value of resistance involved in the circuit, what is the value of capacitance or inductance involved in the circuit. Now before we start actually finding out these values, we firstly have to make it sure that what are the components involved, and then we will find out the values, whether it is resistor only, capacitor only, or inductor, or any combination of these three. So see, expression for current clearly shows that it has a leading angle of pi by 6. We know current is leading by some angle somewhere between 0 to 90 only when the circuit is series RC circuit. So it is very sure that circuit will consist of series connection of one resistor and one capacitor. So by the word components mean we need to find R and C. By the word values of components mean we need to find values of R and C in this case. So let's begin to solve this numerical now. So the given expression for voltage is E is equal to 120 sin 314t, and from this what we can find out is frequency. So frequency, that obviously this is 2 pi f, and 2 pi f is equal to 314, so that is why frequency is equal to 50 hertz. So and then current can be taken into account, where we get the value of phi. Phi is equal to pi by 6, that is it is 30 degree. Then these values will be useful further, that is why we found out frequency and phi firstly. Now to find out Z, what we need is, we will find out Z so that we find out the components. Okay, so to find out Z, the usual formula is V upon I, and whenever we write V upon I, V is always RMS value of voltage and I is always RMS value of current. So here we have specifically written as ERMS upon IRMS, but ERMS and IRMS have not been given directly but can be found out very easily. We know this is maximum value of voltage and this is maximum value of current. So maximum value of voltage divided by root 2 becomes RMS value of voltage. Maximum value of current divided by root 2 becomes RMS value of current. So look at this, ERMS is written as 120 by root 2, 120 by root 2. IRMS is equal to 10 by root 2. So this is 10 by root 2. What we get is 12 ohm. So using this impedance and using this phi, we can get the values as R is equal to, we have a formula for R to be found in terms of Z and phi as Z into cos phi. So substitute the values, 12 into cos 30, and we get 10.4 ohm. So look at this, we have found out one of the components. We were supposed to find two components, one is R, the other is C. One component R is found out. C can also be very easily found out. We know the formula, X is equal to Z sin phi, XC is equal to Z sin phi, and values can be substituted to get the value of XC as 6 ohm. But we also know XC is equal to 1 upon 2 pi FC. So C can be written as 1 upon 2 pi f XC. Substitute the values already known and the value of XC obtained here, and what we get is C equal to 530.52 microfarad. So look at this, we have found out both the components involved in this series circuit, R 10.4 ohm, C 530.52 microfarad. Now we need to find out active and reactive power of the circuit, which is very easy to be found out. We know the formula for active power. It is P is equal to VI cos phi. Substitute the values. One more thing to be noted is V is RMS value and I in the formula is also RMS value. Voltage RMS value can be given as 120 by root 2. Look at this. This was already done over here. And current's RMS value is equal to 10 by root 2. This was already done over here. So this is very easy to understand. Cos phi obviously is cos 30 and this becomes 519.62 watt. Now reactive power can also be found out by using the formula VI sin phi and RMS values of voltage, RMS value of current and sine of 30. So if calculated, what we get is 300 VAR. So I hope this numerical was very interesting as we found out the components involved in the circuit just by looking at the expressions of voltage applied to the circuit and current that was flowing in the circuit. And finding out power was very easy. So I hope this numerical was understood and you will be able to solve such similar numericals. Thank you.